Let's take a closer look at BigQuery's support for nested and repeated fields and why this is such a popular schema design for enterprises. I'll illustrate by using an example from a real business running on GCP. Gojek is a ride booking service, among other services, that's based out of Indonesia. And they process over 13 petabytes of data on BigQuery per month from queries to support business decisions. What kind of decisions? For Gojek, they track whenever a new customer places an order, like hails a ride with their mobile app. That order is stored in an orders table. Each order has a single pickup location and drop-off destination. For a single order, you could have one or many events like ride ordered, ride confirmed, driver en route, drop-off complete, etc. As a data engineer, how would you efficiently store these different pieces of data in your data warehouse? Keep in mind, you need to support a large user base querying petabytes per month. Well, as you saw earlier, we could store one fact in one place with the normalization route, which is typical for relational systems. Or we could go the fully denormalized route and just store all levels of granularity in a single big table, where you would have one order ID, like 123, repeated in a row for each event that happens on that order. Faster for querying, sure, but what are the drawbacks? For relational schemas, often the most intensive computational workloads are joins across very large tables. Remember, RDBMS systems are record-based, so they have to open each record entirely and pull out the join key from each table where a match exists. And that's assuming you know all the tables that need to be joined together. Imagine for each new piece of information about an order, like promotion codes or user information, and you could be talking about a 10+ table join. The alternative has different drawbacks. Pre-joining all your tables into one massive table makes reading data faster, but now you have to be really careful if you have data at different levels of granularity. In our example, each row would be at the level of granularity of a specific event, like driver confirmed, for any given order. What does that mean for an order ID like 123? It's duplicated for each event on that order. Imagine if you're looking to join higher level information like the revenue per order, and now you have to be exceedingly careful with aggregations to not double or triple count your duplicate order IDs. See the problem? One common solution in enterprise data warehouse schemas is to take advantage of nested and repeated data fields. You can have one row for each order and repeated values within that one row for data that is at a more granular level. For example, you could simply have an array of timestamps as your events. Let's see an example to illustrate this point. Here you see it clearly. Shown here on the screen are just 4 rows for 4 unique order IDs. Notice all the gray space in between the rows? That's because the event status and event time is at a deeper level of granularity. That means there are multiple repeated values for these events per each order. An array is a perfect data type to handle this repeated value and keep all the benefits of storing that data in a single row. I mentioned the field event status and event time. If this is one giant table, what is a dot doing in those column names? There are no other table aliases we've joined on, so what's up with those fields? Event, pickup, and destination are what are called struct or structure type data fields in SQL. This isn't BigQuery specific. Structs are standard SQL, and BigQuery just supports them really well. Structs you can think of as pre-joined tables within a table. So instead of having a separate table for events and pickup and destination, you simply nest them together within your main table. So let's recap. You can go deep into a single field and have it be more granular than the rest of your data by using an array data type, like you see here for status and time. And you can have a really wide schemas by using structs, which allow you to have multiple fields of the same or different data types within them, much like a separate table would. The major benefits of structs is that the data is conceptually pre-joined already, so it's much faster to query. People often ask, with really wide schemas, like 100 columns, how is it still so fast to query? Remember, the BigQuery is column-based storage, not record-based. If you did just a count order ID here to get your total orders, BigQuery wouldn't even care that you have 99 other columns, some of which are more granular with array and data types. It won't even look at them. That's what gives you the best of both worlds. Lots of data all in one place and no issues with multiple granularity pitfalls when doing aggregations. Now it's your turn to practice reading one of these schemas that has nested and repeated fields. Take a moment and spot those structs. As a hint, you can look at the field name to see any field with a dot in the name, or you can look at the data type for any field values of the type record, which means struct. Did you get them all? Here are the 4 structs in this dataset you saw earlier: events, pickups, destination, and duration. Duration is a new one, but we can simply keep adding more dimensions to our dataset by adding more structs. Remember, structs let you build really wide and informative schemas. Now it's time to go deep. Find the array data types in this schema. As a hint, look at mode and find the repeated values. Have you got them? In this schema, the repeated value is the event struct, which means the struct happens to have all columns in it that are all repeated. You can see that in the preview of the data below. The status field is an array of all the statuses for order, and the time field is an array of all the timestamps for that order. A critical point I like to make here is that struct and array data types in SQL can be absolutely independent of each other. You can have a regular column in SQL be an array column that has nothing to do with any struct. Likewise, you can have a struct that has 0 array field types in its columns. The benefit of using them together is arrays allow a given field to go deep into granularity, and structs allow you to organize all those useful fields into logical containers instead of separate tables. So here's the cheat sheet. Structs are of type record when looking at a schema, and arrays are of mode repeated. Arrays can be of any single type, like an array of floats or an array of strings. Arrays can be part of a regular field or be part of a nested field nested inside of a struct. A single table can have 0 to many structs, and lastly, the real mind-bending point is that a struct can have other structs nested inside of it, as you will soon see in your upcoming lab, which uses the real Google Analytics schema. We've been talking a lot about nested and repeated fields, so you're probably wondering what to do with your existing star schema, snowflake, and third normal form data. The great news is that BigQuery also works well with those schema types. Use arrays and structs when your data naturally arrives in that format, and you'll benefit immediately from optimal performance. For the other schema types, bring them directly to BigQuery, and you'll likely be pleased with their performance as well. Lastly, if you really love this topic and how it all came about, you can check out the original Dremel white paper that Google published in 2010. Dremel being the massively parallel SQL engine that powers BigQuery. These diagrams come from that paper and explain how this nested structure is stored when you're using column-oriented storage. As you see here, every column, in addition to its value, also stores 2 numbers: definition and repetition levels. This encoding ensures that the full or partial structure of the record can be reconstructed by reading only requested columns and never requires reading parent columns, as is the case with alternative encodings. I'll link the white paper if you want to read more.